Welcome back to the deep dive. We've got a truly fascinating stack of sources in front of us today, all pointing towards something, well, fundamental, something powering the digital world you interact with every single day, often without even realizing it.
Hmm,
We're talking about the physical infrastructure behind artificial intelligence.
that's right. And think about it for a second. AI is just woven into the fabric of our modern lives now, isn't it?
Totally.
Whether you're asking a voice assistant for the weather, or maybe scrolling through personalized recommendations on your favorite streaming service, or even a shopping site.
Yeah, or you see those headlines about AI helping doctors
Yeah,
with complex diagnostics, treatment plans.
exactly. AI isn't abstract anymore. It's concrete, it's useful, and, well, it's pretty much every way.
It's integrated so seamlessly now, it feels almost invisible sometimes. It helps doctors spot things in scans, guides your self-driving car features, or just plays the perfect next song.
Right.
But this isn't magic, is it? This
Yeah.
isn't happening just like in the cloud, floating somewhere.
Definitely not. It requires physical hardware,
Hmm.
massive amounts of processing power, and a very real, very tangible foundation.
Exactly. And that's the hidden world we're exploring today. While we interact with AI through software, apps, our devices, the incredible computational heavy lifting.
Yeah, the learning, the data processing, all those complex calculations that let AI understand and predict and, generate responses.
All that happens in physical locations. These are what we're increasingly calling the new infrastructure. Specialized data centers built, optimized specifically for the demands of AI.
It's a rapidly evolving landscape. It's not like the traditional data storage facilities of, say, 10 years ago.
Right. Our source material today takes a real deep dive into this transformation. It helps us understand what these AI data centers actually are, why they're needed on such a massive scale.
And, critically, why certain geographic locations are becoming absolutely crucial hubs for this new infrastructure.
So to ground this, we're going to focus specifically on North Carolina today. It's emerging as a really significant player in this space.
hmm And then we'll drill down even further. Look at the details of a major concrete project there, one being undertaken by a company called White Fiber.
Okay, so our mission for you, the listener, is really to pull back the curtain. We want you to walk away understanding the physical reality powering the AI you use constantly.
Yeah, why are places like North Carolina suddenly so vital to this whole global AI ecosystem?
Exactly. And what's the true scale? The investment, the physical footprint involved? What's the ripple effect of these massive facilities on the communities where they actually get built?
And this White Fiber project in Madison, it gives us the perfect lens to examine all those questions. It really brings it down to earth.
It's about understanding the engine behind the intelligence, isn't it? A fundamental shift in infrastructure with some pretty broad implications.
Absolutely.
So let's dive right in. Section 1, AI's ubiquitous presence and its hidden engine. We've touched on how AI is everywhere now. The sources really emphasize just how integrated it's become, almost like mundane.
They really do. I mean, think about waking up, asking your smart speaker for the news or to control your thermostat. That's natural language processing right there. Smart home automation, all powered by AI.
Or ordering groceries online.
Yep. AI is likely powering the recommendation engine, suggesting items based on what you bought before, or even optimizing the delivery route to get it to you faster.
And healthcare. That's a big one the sources mention. AI analyzing massive data sets of medical images, X-rays, MRIs, CT scans.
Precisely. Helping radiologists identify potential issues faster, maybe with greater accuracy, sometimes even spotting tiny things a human eye might initially miss.
And it's moving fast into areas like transportation, too. Your navigation app rerouting you based on real-time traffic. That's AI processing complex patterns.
Or the advanced driver assistance systems in newer cars,
Yeah.
using AI for things like adaptive cruise control, keeping you in your lane, or even emergency braking.
Right. These aren't just simple programs anymore.
Not at all. They're complex systems. They can learn, recognize patterns, make predictions, interact in ways that feel increasingly intelligent. The source highlights this widespread adoption. Commerce, health, transport, entertainment.
And that's the fundamental why, isn't it? Why we need this huge new infrastructure.
Exactly. It's not just about running a few simple tasks anymore. It's supporting millions, maybe billions of users, everyone generating data, requiring rapid, complex processing constantly.
So it sounds like every tap on your phone, every voice command, every medical scan analyzed, every traffic update, it's all sending data somewhere to be crunched by AI.
That's a really good way to put it.
Yeah.
Each interaction, each application, it draws on the capabilities of these AI models.
And supporting that sheer volume, that constant stream of processing, needs immense computational muscle.
Immense.
Yeah.
And muscle that exists in the physical world. The sophistication we now take for granted, understanding all sorts of accents, analyzing subtle visual cues and medical images, predicting traffic flow better and better.
All that requires high-density computing power. Stuff traditional infrastructure just wasn't built for.
Exactly. It wasn't designed for this kind of load.
So the more useful AI gets, the more accurate, the more integrated, the greater the demand on whatever physical system is running it, a direct link.
Absolutely direct. The scale and complexity of modern AI workloads translate straight into this unprecedented demand for specialized physical infrastructure. It's not just about storing the data to train the AI. It's providing the compute power to actually run these intelligent systems and, train the even more complex ones for the future.
Which brings us squarely to the question, what is this new infrastructure? What actually makes it different?
Okay, yeah, let's unpack that section 2. What exactly is an AI data center?
Because when we say data center, in the AI context, it's not just a big server room, is it? Or is it?
No, that's a crucial distinction. An AI data center is fundamentally different. Different in its design, its purpose.
How so?
Well, traditional data centers might house servers for, say, websites, cloud storage, basic business applications, often focused on reliable data access, general computing tasks.
Right. Keeping things online.
Exactly. An AI data center, though, is optimized for a very specific type of workload. It's all about that intense parallel processing required for artificial intelligence.
Okay, so what are the key components then, according to the sources? What makes an AI data center tick? What's different inside?
The sources highlight several critical elements. First up is AI model deployment.
Okay.
Now, this isn't just storing the huge amounts of data needed to train an AI model, although, yeah, that happens too.
Right.
Is where the trained AI algorithms themselves actually live and run.
Okay, so the brain itself is running there.
Pretty much. When you ask Siri a question or an AI analyzes that medical image we talked about, the actual AI model, the intelligence, is executing on servers in one of these centers, processing your request, your input in near real time.
And that constant active processing, it needs specialized systems, right?
Absolutely. Which brings us to the next point, specialized hardware. This is where it gets really interesting, like you said earlier, and different from the processors most people know.
Yeah, CPUs we know, central processing units.
Right. Traditional computing relies heavily on CPUs. They're great for handling tasks one after another, complex single operations. But AI workloads, especially training deep learning models and running complex inferences, they involve just vast numbers of simultaneous, relatively simpler math operations. Think matrix multiplications, linear algebra, that sort of thing.
Okay.
For that, AI data centers use processors like GPU's graphics processing units, originally designed, to render millions of pixels for video games.
Right, I know GPUs from gaming.
Exactly. And also, TPU's tensor processing units. These are custom-designed chips, like by Google, specifically to accelerate machine learning.
So if a CPU is like one super smart person solving a problem really fast, a GPU or TPU is more like thousands of people working on different small parts of a giant problem all at once.
That's a great analogy. Yeah. GPUs and TPUs excel at parallel processing. They can perform thousands, even millions of calculations simultaneously. That architecture is just perfectly suited for the computations in training neural networks, like adjusting billions of parameters across huge data sets, and for running those trained models efficiently to give you quick responses.
So that parallel capability is absolutely essential for modern AI.
Non-negotiable for the scale and performance needed today. And it's worth remembering, these specialized chips, they're not only incredibly powerful,
Must be expensive.
very expensive, and they generate a ton of heat.
Okay. Which I guess ties into the next component, the data itself and the energy needed to handle it all.
Precisely. Any data center stores data, obviously. But AI centers are defined by the sheer scale of data storage and processing. The sources mention processing petabytes of information continuously.
Petabytes. Remind me how big that is again.
Okay, so a petabyte is 1,000 terabytes.
Yeah.
And 1 terabyte maybe holds, what, 250,000 photos?
Yeah.
Or around 500 hours of HD video?
So a petabyte is astronomical, like truly massive amounts of data. The kind you see in like scientific research or language models.
Exactly. We're talking data lakes the size of small oceans, easily.
Yeah.
And it's not just sitting there static.
Right, the AI is constantly using it.
Constantly accessing, analyzing, learning from this data, this needs super high-speed network connectivity inside the data center and incredibly fast input-output from the storage systems. It's a really dynamic, high-throughput environment.
And constantly accessing and processing petabytes of data on thousands of these power-hungry GPUs, that must require an equally astronomical amount of energy.
You got it. That leads straight to the final fundamental core component, power infrastructure.
The electricity bill must be insane.
Probably. But more than that, a reliable, massive, and stable electricity supply is maybe the single most critical requirement, even more so than for traditional data centers. Well, these places run 24/7, nonstop. The power consumption of thousands of high-performance GPUs, plus all the extensive cooling systems needed to manage the heat they generate. It's just enormous.
It sounds like just keeping these things from literally melting down is a major engineering challenge on its own.
Oh, it absolutely is. Cooling alone can eat up a huge chunk of a data center's energy budget. Running thousands of these chips continuously consumes megawatts of electricity. Megawatts.
Wow.
So securing enough reliable power becomes a primary factor in just choosing where to build, let alone running the place day to day. Downtime? Even for a moment.
Could cost millions. Disrupt services for tons of people.
Exactly. Millions of users could be relying on the AI applications running there. So you can see why just having a big server room doesn't cut it. You need entirely different infrastructure built from the ground up for this specific intense workload.
And understanding those requirements makes it much clearer why these facilities aren't just popping up randomly everywhere. They need very specific conditions.
Precisely. Which brings us right to our next point. Where are they being built and why there?
Okay, Section 3. North Carolina's emergence as an AI hub. So given these places are incredibly complex, need huge power, house super expensive hardware, why is a state like North Carolina suddenly becoming such a key player in this whole AI infrastructure game? What makes it attractive?
Well, the sources point to North Carolina having this potent combination of strategic advantages. It makes it particularly well suited for these hyperscale data centers, especially the ones geared towards demanding AI workloads. It's not just one single thing, but a confluence of factors.
Let's start with location. The source specifically calls out the Piedmont Triad region.
Right, so the first advantage is strategic location. The Piedmont Triad, which is where this white fiber project we'll discuss is located, sits in a pretty central position within North Carolina itself.
Okay, and why does that central position matter so much? Is it about travel times for workers?
Not so much workers, but data travel times, what we call latency. For many AI applications, especially ones needing real-time responses, the time it takes data to travel from you, the user, to the data center and back again is absolutely critical.
Like asking a voice assistant or using AI navigation while you're driving.
Yeah,
Every millisecond counts there.
exactly.
Yeah.
Being centrally located within a C, the source says within about 100 miles of major population centers like Charlotte, Raleigh, Durham, Greensboro. That means lower latency for a big chunk of the state's population and businesses.
Makes sense. Faster response times.
But it's not just about serving North Carolina. The location also offers really excellent connectivity to major markets outside the state, thanks to its proximity to major highways and, importantly, existing robust fiber optic backbones.
Oh, the internet's plumbing.
Basically, yeah. Data needs to flow quickly, not just locally, but nationally, internationally. This existing infrastructure ensures efficient data transfer to and from other data centers and users across the country.
Okay, so geographic position is key for speed and connectivity. What's another big advantage for NC?
The state benefits hugely from its academic resources. Proximity to major research universities is a massive draw. We're talking about institutions like those clustered in the Research Triangle Park area, UNC Chapel Hill, NC State, Duke, plus others across the state too.
How does having universities nearby help build and run, these complex data centers? Is it just about hiring grads?
Hiring grads is a big part of it, definitely. It provides access to a deep, constant supply of highly skilled talent. These universities produce graduates in computer science, electrical engineering, mechanical engineering. You need those for the cooling systems.
Right.
Network architecture, cybersecurity, all fields absolutely essential for designing, building, operating, maintaining these incredibly complex, high-tech facilities. These aren't entry-level jobs you can just fill easily. They need specialized education.
And I imagine the relationship goes deeper than just hiring people.
Oh, for sure. The sources suggest these academic partnerships can really drive innovation within the industry itself. Universities are doing cutting-edge research in areas directly relevant. Think developing more efficient cooling tech, optimizing how AI hardware and software work together.
Better network efficiency, security.
All of that. Companies can collaborate with universities on research projects. It creates this kind of symbiotic relationship that pushes the technology forward.
Okay, so you've got the physical location for performance, the universities for the brain power, and the workforce. What's the third major factor pulling these facilities to NC?
It's the existing technology ecosystem. North Carolina, especially the Research Triangle and the areas around it, already has a significant and growing concentration of tech companies.
Right. It's already a tech hub to some extent.
Exactly. And that creates what economists sometimes call a virtuous cycle or synergy. Existing tech companies attract the infrastructure they need, like these hyperscale data centers.
And then the infrastructure attracts more tech companies.
Precisely. The presence of robust, cutting-edge infrastructure makes the region even more attractive for other tech companies to move there or expand. It's like a magnet effect.
Once you get a critical mass of tech activity in the support structures, it just starts pulling in more of the same.
You got it. It lowers the barriers for new tech companies. The talent pool's there, the network infrastructure is solid, the necessary computing power is becoming readily accessible. Plus, it helps that hyperscale data centers, maybe not AI-specific ones on this scale until recently, already call NC home.
So there's existing know-how.
Yeah, there's operational knowledge in the state, a base of skilled labor familiar with data center environments, established relationships with crucial partners like the power companies and fiber providers. That all smooths the path.
And we shouldn't forget the role of state policy, right? The source mentioned incentives.
That's right. Good point. Economic incentives also play a significant role. States actively compete to attract these massive investments. They represent high-value, long-term capital projects that bring big economic benefits. North Carolina, like many states, offers tax benefits and other incentives for qualifying data center operations.
So while the core needs might be location, power, talent, these incentives can kind of sweeten the deal, make NC stand out.
Exactly. They show the state government is supportive. It recognizes the industry's importance for future economic growth. It signals a welcoming environment for these, billion-dollar investments. Put it all together, strategic location, academic strength, existing tech ecosystem, and supportive incentives. And you see why NC looks like a prime spot for building the foundation of the AI age.
That makes a lot of sense. It's a mix of sort of natural advantages and deliberate choices. Okay, now to make all this really concrete, the sources give us a detailed look at one specific project, the White Fiber Madison Data Center. And this wasn't just finding an empty field, right? It involved transforming an older industrial site.
Yeah, this White Fiber Madison project is a fantastic real-world case study. It really encapsulates a lot of the trends and factors we've just been talking about. It shows the scale, the speed, and that whole transition involved in building this new digital infrastructure.
And it has an interesting history tied to the local community, doesn't it, according to the sources?
It does. The site used to be a large unified textile plant. That history is significant because, well, its closure back in February 2025 resulted in the loss of 250 manufacturing jobs.
Oof. Yeah.
So it's important context. You have to acknowledge the impact on the community, the end of one era, before you talk about the beginning of a new one on the very same piece of land.
It's a really clear, tangible example of that broader economic shift we see everywhere, moving from traditional manufacturing towards, well, the digital and tech economy.
Absolutely. And the transition timeline at this specific site was incredibly fast. It really illustrates the speed these companies feel they need to move at to meet demand.
What did the sources say about the timeline?
Okay, so the textile plant closes February 2025. Just a few months later, June 2025, White Fiber acquires the property, paid $45 million for it. Renovation work to convert the facility into a data center started right away in the summer of 2025.
Wow, no messing around.
None. By September 2025, the initial power capacity, 24 megawatts, became available. That let them start bringing the first server clusters online. And the first phase of the data center was fully operational by December 2025.
That is remarkably fast. Acquisition in June, operational in December. Less than 6 months to stand up a complex, high-power facility and on a repurposed site, no less.
It really underscores the urgency driving this whole industry. The demand for AI computing power is just so high, companies are under immense pressure to build capacity as quickly as they possibly can. And it also highlights that job transition we mentioned from manufacturing roles to the types of skilled tech jobs needed to run this place.
Let's dig into the scale of this project. The numbers the sources provide are kind of mind-boggling.
They really are. The property itself is substantial, 96 acres. That indicates not just the footprint of the current facility, but, significant room for future expansion right there.
96 acres. Okay. And the building itself.
The facility space is immense. 1 million square feet. Try to picture that. A building roughly the size of, 17 American football fields laid end to end, all dedicated to housing servers, network gear, cooling infrastructure.
1 million square feet of digital engine. Wow. And the cost comparison you mentioned earlier between the initial purchase and the total investment, that's really telling too.
It really is. So the initial cost to acquire the old textile plant property was $45 million.
Okay.
But the sources state the total investment projected for the complete project is a whopping $1 billion.
$1 billion. Compared to $45 million for the land and buildings, where does that massive difference, that nearly $950 million extra, actually go?
That billion-dollar figure really hammers home the scale of investment needed for the specialized infrastructure that goes inside that million square feet.
Ah, the expensive hardware.
Exactly. That includes hundreds of millions, probably closer to $1 billion eventually, just for the sheer volume of specialized hardware, those GPUs and TPUs we talked about. Plus, the incredibly sophisticated power distribution systems.
The cooling.
Advanced cooling technology, yeah. Maybe even liquid cooling for the really dense AI racks, the high-speed networking gear connecting everything, all the backup systems, generators, batteries needed for that continuous, reliable operation.
So it's definitely not a real estate play, it's an infrastructure play. The building is almost just the shell for incredibly expensive, high-density tech.
Precisely. It's a long-term, heavy capital commitment to building foundational compute power. And speaking of power, the specs for White Fiber Madison really drive home the energy demands of AI.
Okay, what are those specifics? How much power are we talking?
The initial power deployment, the amount available by September 1st, 2025, was 24 megawatts, MW, enough to get the first phase up and running.
24 megawatts. Already sounds like a lot.
It is. But the full development involves a 99 milliW agreement with Duke Energy.
99 megawatts. You mentioned earlier, that's like a small town's worth of power.
It really is. 99 megawatts is a substantial power load for just one single facility. It's far, far beyond what even a large traditional office building or factory would need. The sources stress this allocation supports massive computing resources. It just illustrates that exponential leap in power needs when you go from general computing to dense AI processing.
Can you put that 99 milliW in context somehow?
Okay, well, the average U.S. home uses maybe about 1.2 kilowatts per hour continuously. That's 0.00012 milliW. So 99 megaBO is equivalent to the continuous power needs of roughly 82,500 average American homes.
82,000 homes worth of power for one facility. That's incredible. And the potential is even higher, you said.
Yes. The sources know there's future expansion potential to scale the site up to 200 megaW if they get regulatory approval.
200 megawatts.
200. If White Fiber hits that 200 million W mark, this one facility would consume power equivalent to a city of over 160,000 homes. It would absolutely be one of the largest AI data centers in the region, maybe even the country, just based on its power appetite alone.
200 megawatts.
Yeah.
For a single AI facility. That just hammers home the point about power infrastructure being the absolute limiting factor and a critical piece of the puzzle. It also raises that crucial question again, where is all that power coming from? And how will the grid handle this kind of escalating demand?
It's the question reverberating across the industry and for utilities everywhere. These demands are so immense, they're fundamentally changing how utilities have to plan their generation, their transmission infrastructure, everything.
Okay, so we've covered the massive scale, the critical requirements. Now let's zoom out a bit. Section 5, the impact of data centers. Beyond the servers, what's the broader effect of projects like White Fiber's on the communities where they're built, on the state as a whole, beyond just the building itself? The sources highlight several ripple effects.
They do. They point to pretty significant economic and community impacts that extend far beyond the facility's fence line. And actually, let's just quickly revisit those strategic location benefits for a second.
Okay.
Because they aren't just benefits for White Fiber itself. They become benefits for the whole region.
How do you mean?
Well, those strategic location benefits we've talked about, the central position in NC, the great transport links via highways for logistics, the robust network infrastructure with all that fiber optic cable, that makes the surrounding area more attractive, not just for this data center, but for other businesses too. Businesses that might need low latency access to it or just benefit from the same improved infrastructure. The presence of a major hyperscale hub boosts the digital readiness of the entire region.
Gotcha. And the economic incentives we mentioned, the state offers those because they expect these broader positive impacts, right?
Exactly. The incentives bring the project in, and the project itself enhances the region's overall attractiveness. It feeds itself.
Okay. So what are the direct economic and community impacts the sources detail? Jobs must be a big one.
A key impact is job creation, definitely. As we saw with the Madison site's history, these projects represent a big shift in the type of employment available. While the textile plant closure meant losing manufacturing jobs, the data center brings high-skilled technology positions.
What kind of jobs?
Site engineers managing the complex building systems, IT technicians maintaining servers and networks, cybersecurity pros, various operational staff, security personnel, that sort of thing.
And how do these new tech jobs compare to the old manufacturing ones? Is it an easy swap?
Well, the sources indicate these tech jobs are typically higher paying than traditional manufacturing roles. So that's a net gain in economic value per employee for the community. But, as you hinted, they require very different skill sets.
Right, so there's a challenge there, workforce adaptation.
Exactly. It's not a direct one-to-one replacement of skills. So
Mm.
training, education, they become absolutely crucial.
Which probably ties into another impact the sources mention.
It does. The presence of a major tech facility like this tends to foster business attraction. Related tech companies, especially those developing AI applications or services that need to be physically close to massive compute power, they often cluster around these hyperscale data centers.
So it's not just the data center moving in, but potentially other companies following suit, creating a little ecosystem.
That's often the pattern, yeah. Proximity offers technical advantages, lower latency, higher bandwidth, which makes operations more efficient for companies that are heavy users of AI or other data center services. But it also helps create that ecosystem vibe. It attracts other skilled workers to the area. It encourages the development of local support businesses like specialized maintenance firms or IT consultants. It just generally contributes to creating a more vibrant tech hub environment. It can be a really powerful engine for local economic development.
And all this economic activity, that must translate into revenue for the local government too.
It does. The source highlights tax base expansion. These tech facilities are enormous capital investments. They generate significant property taxes based on the value of the land, the buildings, and importantly, all that super expensive equipment inside.
Right, the billion-dollar investment.
Yeah. They also contribute through business taxes, potentially sales taxes on equipment purchases.
Yeah.
It adds up.
And those taxes can then help fund local services, presumably.
Precisely. The substantial tax revenue generated can help fund local schools, public safety, infrastructure improvements, maybe road upgrades needed to access the site, and other essential community services. This can potentially help offset some of the costs the community and state incurred in providing the necessary infrastructure, especially those massive power upgrades.
And connecting back to that workforce adaptation challenge we mentioned, there's also an impact on education, right?
Absolutely. The demand for skilled labor created by these data centers
Mm-hmm.
and the tech ecosystem that grows around them directly influences educational opportunities. Local community colleges, universities, they have a strong incentive and a real opportunity to develop or expand courses specifically tailored to data center operations.
Things like network administration, cloud computing, cybersecurity.
Exactly. All those related tech fields. It creates concrete pathways for local residents to actually gain the skills needed for these new jobs.
So it helps local people qualify for the new roles being created, maybe even people displaced from older industries.
That's the idea. It helps ensure the benefits of this huge infrastructure investment are accessible to the local workforce. It can mitigate some of the negative social impacts of that industrial transition we saw with the textile plant closure. So yeah, the impacts are really multifaceted: economic growth, shifts in the job market, more tax revenue, better educational opportunity.
It's a really complex picture, isn't it? Shows how these massive digital facilities are deeply intertwined with the physical and social fabric of the places they land. Okay, looking ahead now. Section 6. The future of AI infrastructure. This rapid development feels like just the start of something bigger. What do the sources suggest about future trends? For AI infrastructure generally, and maybe for North Carolina's place in it.
The source outlines a few key trends that are not only driving the current boom, but will really shape how these facilities evolve and continue to grow in the coming years.
What's the biggest, most significant trend they identify?
Undeniably, the most impactful trend is just exponential growth. The source highlights a truly staggering fact. AI processing demand is doubling annually.
Doubling every single year.
Doubling every year. Think about that rate of growth. It's most hard to grasp.
That's an incredibly aggressive growth curve. Almost unbelievable.
It is. And it explains why companies are investing billions and building places like White Fiber Madison so incredibly quickly. They are literally racing to keep pace with this soaring demand for compute power. Driven by advances in AI models, they're expanding applications across, well, every sector.
And this isn't seen as a temporary spike?
No, this exponential growth in demand is projected to continue for the foreseeable future.
And that kind of growth rate, it must put immense pressure on resources, especially energy, right?
It absolutely does.
Yeah.
Which leads directly to the next major trend the source identifies,
Mm.
a growing sustainability focus. With the kind of massive power requirements we've been talking about, 99 milliW, maybe scaling to 200 milliW for just one site,
Right.
the energy footprint of AI data centers is just enormous.
Yeah.
This makes energy efficiency and sustainable power sourcing increasingly critical. It's driven by both environmental concerns and operational costs. Power is expensive.
So there's a big push for these facilities to become greener. It's not just PR.
No, sustainability becoming a top priority, not just a nice-to-have. Future facilities, next-gen designs will incorporate advanced energy-saving tech, more efficient power distribution, better cooling, like liquid cooling for those high-density racks, which is way more efficient than traditional air cooling.
Even using AI to manage the power systems themselves.
Exactly. AI-driven power management systems that optimize energy use in real time. And, critically, the source notes a strong trend towards incorporating and directly sourcing renewable power.
Connecting back to that big question, where does all the power come from?
Exactly. Data center operators are signing what are called power purchase agreements, or PPAs, directly with renewable energy projects, solar farms, wind farms, trying to match their huge energy consumption with clean sources.
Some are even building renewables on site.
Yeah, exploring building on-site generation where it's feasible. This is really essential evolution because the sheer scale of their demand means they can actually be a significant factor in accelerating the transition to a cleaner energy grid overall. But it also raises complex questions about grid stability, about the infrastructure needed to deliver that much renewable power reliably, 247, to these specific high-density locations.
It sounds like the AI industry's growth could either, supercharge the move to renewables or put an incredible strain on existing fossil fuel infrastructure if they don't get ahead of their energy needs.
It's a critical balancing act, a major challenge the entire industry is grappling with right now. Another trend the source mentions is the rise of edge computing.
We touched on this briefly. What exactly does that mean again, moving compute closer to the user?
Essentially, yes, edge computing means moving smaller, more distributed data centers physically closer to the users, or closer to the devices that are generating data and needing to process it in real time.
Okay.
So instead of sending all data back to a massive centralized cloud data center, maybe hundreds or thousands of miles away,
Right.
processing happens at the edge of the network, closer to where the action is.
For things that need basically instant responses, like those autonomous vehicles or factory automation examples.
Precisely. For use cases where milliseconds of latency matter, critically self-driving cars, processing sensor data for immediate decisions, or industrial robots coordinating actions on a factory floor sending data far away is just too slow.
So you need the processing right there.
Pretty much. Smaller edge data centers located in cities or even on-site at factories or hospitals provide that necessary low latency. This suggests a future network where you have these large, hyperscale core data centers like White Fibers, handling the massive training datasets and less time-sensitive AI tasks, complemented by a distributed network of smaller edge facilities for those real-time AI applications.
So the infrastructure map gets more complex, different types of data centers for different jobs. Interesting. And where does North Carolina fit into these future trends, according to the
The
sources?
source material strongly positions North Carolina leadership in this evolving landscape. Based on that combination, we discussed the strategic location, access to talent and research, the growing tech ecosystem, supportive state policies. The state isn't just seen as participating in this AI infrastructure boom. It's positioned to be a leader. Projects like White Fiber Madison aren't viewed as isolated incidents. They represent the leading edge of what's expected to be continued significant development in the region.
So the foundation is really in place for continued growth in North Carolina as a key hub for this AI infrastructure build-out.
That's certainly what the sources suggest. The conditions are favorable. And that exponential demand for AI compute power means the need for these facilities will only continue to grow, likely solidifying North Carolina's role in building the physical backbone of the digital future.
Okay, so we've taken quite the deep dive today. We started with just how pervasive AI has become in your everyday life, from smart assistants to medical diagnostics, and reminding ourselves this isn't magic, it requires real physical power.
hmm Then we explored what makes an AI data center unique. That specialized hardware like GPUs and TPUs, the need to process petabytes of data constantly, and that fundamental reliance on massive, reliable power infrastructure.
We looked at why North Carolina has emerged as such a key player in this space, leveraging its strategic location for low latency, its strong universities for talent and innovation, that existing tech ecosystem, and supportive state incentives.
And we used the White Fiber Madison project as a really concrete example, illustrating the sheer scale, 96 acres, a million square feet, $1 billion investment, and those incredible power demands, starting at 99 megawatts with potential to double that.
Right, and we saw how that project is transforming an older industrial site, bringing a significant shift in the local job market from manufacturing to tech.
Finally, we examined the future trends shaping this whole industry. That relentless exponential growth of AI processing demand, the increasing critical focus on sustainability and sourcing renewable energy, and the rise of edge computing, bringing AI power closer to users for real-time applications.
So understanding this foundational infrastructure, it really gives you a clearer picture of why AI is advancing so rapidly and where the physical building blocks of our increasingly intelligent digital future are actually being constructed.
Yeah, these aren't just abstract tech concepts floating in the cloud. They have physical addresses. They have a profound economic impacts on communities
Yeah.
and significant environmental considerations tied directly to their energy consumption.
It provides the physical context for the digital world we increasingly live in.
Well said.
Absolutely.
Okay.
And based on everything we've explored from the source material today, particularly that almost unbelievable exponential growth rate of AI demand, doubling every year, and the critical need for power that comes with it. Here's a provocative thought to leave you with.
Okay.
So, what does this unprecedented doubling every year demand for AI processing power truly mean for our global energy landscape? If AI's hidden engine continues to grow at this breakneck pace, how will power grids worldwide and our collective transition towards renewable energy sources possibly keep pace with its seemingly insatiable appetite?